Today on How It's Made. Temporary metal fences, a barrier method that's reliable. Asphalt shingles, they stick to the roof of your house. Expanded polystyrene products, combining foam and function. And hard candies, how sweet it is for you and your dentist. Temporary metal fences securely cordon off dangerous areas on construction sites. At open-air events such as concerts and festivals, they mark the perimeter and help direct traffic flow. Seasonal businesses such as garden centers use them to protect their merchandise from thieves and vandals. It all starts with a giant spool, roughly 7.5 kilometers of galvanized steel wire. A machine called the straightener uncoils the spool and straightens out the wire. The next machine cuts the lengths they'll need to construct the fence panels. A worker feeds those wire lengths into another machine, arranging them in the proper configuration. The lights show him where they go for this particular model of fencing. These lengths will form the panel's vertical pieces. The machine carries them over to the automated welding station. At the welding station, a magnetic arm grabs the panel's horizontal pieces and feeds them one by one into position over the vertical pieces. Then the welding begins. This is electrical welding. A strong electric current zaps the joints, melting the metal and fusing the pieces together. It's faster and neater than traditional welding. The machinery then stacks the welded panels and moves them down the production line. Some panels are soldered on another kind of electrical welding machine. It feeds the horizontal pieces onto the vertical ones using a different technique. But the result is the same. Workers position each welded panel in a manually operated pneumatic press. Then they bend the panel at certain key points. This makes it more rigid and therefore stronger. Next, workers trim off the surplus wire sticking out along the edge of the panel. And then, the final step. They position a round galvanized steel post on each side of the panel. A robotic welder then solders these side posts in place. When it comes time to erect this temporary fence, all they'll have to do is stand each panel in footings that sit on the ground. Then line up the panels side by side and attach them by clamping together the side posts. All the fence components are made of heavy-duty galvanized steel. That makes this temporary metal fence very durable, maintenance-free, and rust-proof. Asphalt roof shingles come in many different colors, textures, and patterns. They're one of the least expensive roofing materials. They're also very durable. Some even carry a lifetime warranty. But they can only go on a roof with a steep enough slope. At the heart of every asphalt shingle is a membrane. It can be made from fiberglass or, like this one, from organic fibers, namely wood chips, recycled cardboard, and paper. The giant rolls of membrane feed what's known as a felt looper. It builds up enough reserve so that workers can change rolls as needed without stopping production. From there, the membrane enters a machine called the saturator, where it's drenched in hot liquid asphalt, a petroleum derivative. When this saturant dries, the membrane will be impermeable. Next comes a thicker asphalt coating mixed with powdered limestone. They apply it to both the top and bottom. This coating will make the membrane flexible. It'll also form a protective barrier against harsh weather. With that coating still wet, they spread colored ceramic granules over the top surface. This gives the shingles their color and makes them resistant to the sun's ultraviolet rays. Granules that don't stick to the wet asphalt get recycled back into the system. Next, they apply a cellophane strip to the back surface so the shingles won't stick together in the package. Then they shower the back surface with powdered stone, also to prevent sticking. Even by this point, the asphalt coating is still piping hot, too hot for the shingle material to be cut to size. So it's off to the cooling section, where cold rollers and water jets bring down the temperature. The next machine applies strips of adhesive asphalt. The sun's heat will activate them, keeping the shingles stuck to each other. The process to this point is the same regardless of color. What can differ from this point on is how the shingle's bottom edge is cut. That determines the shingle's profile. On the way to the cutting station, the shingle material passes through the finish looper. Like the felt looper we saw at the beginning, the finish looper accumulates enough reserve so that production won't come to a standstill if there's a problem. The cutting machine cuts to size and profile. Standard shingles measure 100 by 33.7 centimeters. This model has a straight edge, but some styles have a curved bottom. An automatic counter keeps track of production. The machine automatically stacks the shingles for packaging, usually 21 sheets to a bundle, enough to cover roughly 3 square meters of roof. Asphalt shingles come in about 50 different colors and in about a dozen different shapes and profiles. They wrap each bundle of shingles in paper that's been treated with polyethylene to prevent water penetration. The bundles then go onto pallets, which the factory then wraps in a plastic bag that's water and UV resistant. The warranties on asphalt shingles range from 20 years to lifetime. Generally, the thicker the asphalt and granule protective barrier, the more durable they are and the longer the guarantee. We call it packing foam, but its real name is expanded polystyrene packaging, those feather-light white foam inserts that come with many boxed items. They not only secure the merchandise within the box, they also act as a shock absorber during transport. Polystyrene plastic comes in tiny pellets about 1 millimeter big. The first step is to expand them inside a steam chamber. The 200 degrees Celsius heat causes the pentane gas in the pellets to escape, allowing air to enter the pellets and inflate them up to 40 times their original size. Here are the polystyrene pellets before and after expansion. The factory then bags the pellets in huge sacks. To make expanded polystyrene products, they start by dumping sacks of expanded pellets into what's called the block mold machine. The more pellets they put per cubic meter, the denser the product will be. They steam fuse the pellets together, molding them into a block that's roughly 5 meters long by 1 meter wide by 3/4 of a meter high. This molding process takes from 5 to 20 minutes, depending on the density. A scale built into the conveyor belt weighs the block to make sure it meets specifications. Depending on its density, a block this size can weigh anywhere from 45 to 200 kilograms. Now the block is ready to be cut into whatever product the client has ordered. Expanded polystyrene is best known as a packaging material, but it also has many other uses. Here, they're slicing a block into insulation panels. Builders use expanded polystyrene insulation for basements, roofs, foundations, and inside and outside walls. Regardless of the product, they cut polystyrene blocks using a copper and nickel wire that's electrically heated. It melts the polystyrene on contact, enabling fine precision cuts almost to the millimeter. To make expanded polystyrene packaging, they custom cut the specific shapes required. These squares they're gluing together have been ordered up by a furniture manufacturer. They're designed to fit onto the bottom of chair legs to protect them from damage during shipping. This machine handles more detailed and complex jobs. Its cutting wire is guided by computer software, so it can cut virtually any design. Expanded polystyrene is a low-cost alternative for making commercial signs that can be hung indoors or out. A sign made of high-density expanded polystyrene and coated with a quality exterior paint has an outdoor lifespan of a few years. This moldable product has endless creative and commercial uses. They come in different colors, different shapes and sizes, in flavors ranging from fruity to minty, from tart to tangy. Pretty well everyone enjoys sucking on a hard candy from time to time. For children and adults alike, these sweet treats are just irresistible. Our love of sweets goes back to the caveman, who delighted in eating honey from beehives. In ancient times, people indulged in treats made of honey-covered fruit and nuts. In the Middle Ages, Europeans made candy from boiled sugar, but the high cost of imported cane sugar restricted this delicacy to the wealthy. Candy finally became affordable for the masses in the 1800s with the discovery of a new and domestic source of sugar, the sugar beet. These hard candies aren't mass-produced confections. They are gourmet candies, custom-made and crafted by hand. The candy maker starts by bringing a pot of sugar and water to a boil. Then he adds glucose, a thick syrup made from starch. He heats the mixture to a specific temperature, depending on what type of candy he's making, and lets it cook for about a half hour. Then he stirs in liquid flavoring. Once the mixture is evenly blended, he pours it onto a cooling table. The candy maker has several flavorings at his disposal, from eucalyptus oil to fruit flavors. He also chooses from a wide range of food colorings. This candy will have a strawberry design in the middle, so he and his assistants are working with 3 colors: green for the leaves, red for the berry, and yellow for the background. To enhance the flavor, they add citric acid. Then they keep blending until the candy has cooled down and hardened enough to be malleable. They separate the pieces by color and put each piece on a heated table to slow the hardening process so that the candy will remain pliable. Now they create the design. They form various shapes and sizes and, like a puzzle, put the pieces together to make a jumbo version of the candy design. Once they've assembled the red berry and green leaves and yellow background, they roll on more yellow background, then a layer of red for the outside trim. All that's left is to reduce this giant wad of candy into a bite-sized version. To do that, the candy maker pinches one end and stretches it out to form a long, uniform strand called a rod. He cuts the rod into pieces 60 centimeters long, but he has to keep rolling them until they cool and harden, or else they'll go flat. When the rod is just the right diameter, the design is in perfect proportion. All they have to do now is cut candy-sized pieces. They use the same technique to make kiwi candy, pink grapefruit candy, and banana candy, to name just a few varieties. Want to order up some candy with a personalized message? Here's an L, an O, a V, an E. A Y, O, and U. Again, they create a yellow background and red trim. Then it's more pinching, pulling, rolling, and cutting until the rods are down to just the right size. If you look at the back end of each rod, you'll see the lettering in reverse. That'll be the underside of the candy. When the raw candy comes off the cooling table, it's transparent. To make it opaque or to lighten the color, they pull it on a hook. Here, they intertwine two colors and feed the rod through a special machine that forms bands of pillow-shaped candies. After cooling, they simply break them apart by hand. If you're no sucker for hard candies, no problem. They can also twist rods into lollipops. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net.